All right. We should be coming back together. Those last few seconds. And whenever I stop the alarm, people are like, no, let the alarm play. You'll just want to hear that last little bit. Okay. First of all, I did hear back from Quick Labs. I think I told you this before, and they said things were corrected. So let's see what happens here. We're going to pre-warm the labs and get ready for our lab. So we're going to talk about module 8, which is all about the API gateway, which is like almost, think of like API gateway as like basically like a gateway for your APIs. You know, if you're familiar with like Apogee and MuleSoft and all that, you know, my argument would be that those third parties have way more services and way more API lifecycle management than API gateway. And they are harder to use and set up just because this is like one click and go. Well, I'll say one click, it's a few clicks and go. But so there's trade-offs, right? And they are also extreme, you know, relative to what they offer, they are relatively expensive. So, I mean, to get that 100% of features, you're going to pay more money, but they are robust. Like I got to tell you, they are nice. You know, I've used MuleSoft and Apogee both within the last like 2 years, and I got to tell you that they are nice. But this is really easy to do, and it's going to cover about 80% of what you need. So, you know, can't really knock it. Again, nothing's a panacea, but this is pretty good. So let's talk about API Gateway, developing with API Gateway, because its job basically is to act as a proxy slash gateway slash, not really a load balancer, but kind of like a load balancer for you know, Lambda functions, basically APIs on the back end. It's not just limited to Lambda functions, by the way. By the way, some people say to me, well, can an application load balancer also point towards a Lambda function? Yes, slightly different thing. A load balancer will not do metering, caching, rating, versions. It'll do none of that stuff for you. An API gateway will do all of that for you. So we're going to talk about this. Relatively short by way of comparison. So what is an API gateway? Okay, so an API gateway basically allows you to manage the entire life cycle of your APIs. You get to create APIs, you get to publish them, you get to maintain them, you get to monitor them, you get to secure them, you can authenticate them, you can meter them, you can rate limit them, you can bill against them. If it sounds like a lot, because that's what gateways do. Now, gateways allow you to connect your applications to AWS services on the back end or Lambda functions on the back end, and it will do both RESTful and WebSocket based APIs. So this will, by the way, this gateway will handle hundreds of thousands of concurrent API calls, no joke, right? Now, will it handle like 400,000, 300,000? Well, that depends on your API calls, right? But it will handle at least tens of thousands, if not 100 to 200,000 calls, again, depending on what you got going on. Now, this is a virtual endpoint, so it's not a single point of failure. It looks like a single point of failure, but it's not. It's just like a load balancer. It's not a single point of failure, right? It's virtual. It's an endpoint for many virtual devices. Now, gateway, it's going to create a unified front end. You do need to have an API strategy and a published API definition. And you can like gather that through Swagger and look at the Martin Fowler docs and all that, which, by the way, Martin Fowler's whole discussion on APIs is absolutely sublime. If you're looking for a good practical way to implement APIs or even microservices, go read Martin Fowler's website on either microservices or API like standardization and whatnot. He's really good at it. I actually worked with him at ThoughtWorks last year, and I didn't know who he was. I'm over there like talking to him, and then he was like, "Man, you're pretty good at this," and I'm like, "Oh my God, I just found out who he was." He's one of the signatories, right, for the Agile manifesto. Really deep thinker, practical though. By the way, if you put API gateway in front of your system, it's going to also mitigate denial of service attacks, do throttling, you do authorization. You can easily monetize any, this is for the exam, any question that says, what do you need to do in order to publish your APIs publicly? If the answer includes API gateway, take a look at it, because that's probably going to be the answer. I actually just had that on the DevOps Engineering Pro exam where they're like, oh no, it wasn't even DevOps Pro. It was the machine learning where they were like, hey, we want to monetize our recommendations engine using a SageMaker endpoint. How do we monetize that publicly? And the answer was to put an API gateway in front of it. I was shocked because I remember seeing that on some of the architecture tests. So I was like, wow. I don't know if that was one of the gimme questions or if that was an actual question. So we'll see. Now, API gateway, by the way, will transform the message, as it comes in from the client, as it goes to the back end, as it comes back from the back end, and has it before it's sent to the client. So just know that you can define tons of schemas for request response messages, including changing the payload, the header. It can be validation, transformation, and mapping. This can all be done. So as things come in to the gateway, as they hit the back end, as they come from the back end, and as they go to the client, you can transform those messages just like you can with CloudFront, by the way. If you haven't used CloudFront, CloudFront will also do the same thing. You can change messages once they're received, before they're sent to the back end, as they come from the back end, and then before they're sent to the client. So it's nice. It's a lot of power. We don't always know what to do with that power, right? This can expose backend resources through like Lambda functions, and really any publicly accessible endpoint if you want to. It will transform and validate messages. So it'll validate inputs, it'll validate outputs, right? So this works great. Like if you have a string of APIs on the back end or just a string of services that you want to control access to, by the way, these can be third party. It doesn't all have to be AWS. If you want to, by the way, increase like caching performance, you can put CloudFront in front of it. And actually what will happen, most people don't know this, is that CloudFront will not just cache like JPEGs and videos and stuff like that. It'll also cache API calls. You can choose if you want to do a regional API or an edge optimized API. I know this sounds weird, but you can get caching at the regional data centers in addition to the global data centers that are all over the world. So you can enable caching basically with CloudFront to cache your response, especially if it's like a read type request where you're just like asking for information. If people are doing that frequently, you can just cache that response. The default TTL time to live for those kind of caches is about 300 seconds, by the way. So was that 5 minutes? So you can change that if you want to. You can also throttle. You can set daily quotas. You can grant people, I can't remember what they call them. I think it's like tokens. I want to say it's like a web token or something, where you can basically grant someone the ability to use this token for like 1,000 usages or something like that. This allows you to monetize, by the way. So you grant someone access, but not unlimited access. Maybe they're capped at 50 or 100, requests per second or something like that. So you might want 10,000 a day for partners, like they said below. You can secure it, right? So you can create a private endpoint. You can integrate with other like Cognito or Lambda authorizers. You could use CloudFront as a security layer to protect against attack. You could create a resource policy that you can attach to an API to basically control who can access the API. You can also create an IAM policy. So there's resource-based policies and IAM-based policies for Amazon API Gateway. It's funny, they don't frequently talk about that. But now that I'm thinking about it, you're right, you can access resource policies, but they don't mention that in the listing of systems like SNS, SQS. I don't think API Gateway predated IAM, so I wonder why they did that. I think they did it because I think it's one of those public access things, because you can publicly like make an S3 bucket public. You can make API Gateway anonymously public as well. So Cognito, by the way, is an integrated authentication system with API Gateway. You can also call Lambda code, which could call another authorizer. Those Lambda authorizers that call like Ping Federated or Okta or somebody like that, those are known as custom authorizers inside of API Gateway. So just know you can actually call another system like a ForgeRock or some other authentication system if you wanted to. In this particular case, the client authenticates with Cognito first, so it goes and talks to the user pool. The user pool is actually going to should give it a JWT token, and then that's going to contain a bunch of information that goes back to the client app. Then it's going to call the resource with the token, and then what's happening is that the API Gateway should validate the token with Cognito, and then it's going to invoke the API call. That all happens really fast, by the way. So, and of course you get access to DynamoDB. Where was that dotted line just a minute ago? That should have been there at step 4, right? So a user pool, by the way, is like a user directory. An identity pool is basically what the users are identified as to AWS. You don't always have to have an identity pool if you got a user pool, right? So, but frequently you do. Here, by the way, what we're doing is, things are just getting logged to CloudWatch, right? Things that the API gateway, by the way, will stick into CloudWatch are things like latency, integration latency, like how slow is the back end, any 400s or 500s, either from client side or front side or back side. The number of API calls, did it run into a quota or a throttling limit? So just know the API gateway sits at the center of this whole access to Lambda and other services. You can do caching, you can do content caching, you can export things to CloudWatch, right? Which actually happens by default. So the API gateway sits here, has like a front end for these various Lambda functions. And by the way, that API gateway could front 1,000 Lambda functions. You know, it'd be shocking. I wonder what AWS is using to front all of their API calls. Here's a simple CRUD, right? So create, read, update, and delete against the API call. You know, it's made against the API gateway, which in turn invokes the various Lambda functions to do all the data management, right? So that's what the API gateway could do. And those are the various pieces, like CloudFront in front of it, CloudWatch on the side doing monitoring, Cognito to do user authentication. But what it calls on the back end, the only real limit is frankly your imagination. Is it an API call or not? Now, what if you want to develop with API gateway? What do you do there? I got to tell you, I have done this a lot, and I have to look at the documentation every single time because I got to tell you, it gets complicated. So when you create an API, obviously you have to define things like it's like resources, the paths, the methods are going to be called, and then you got to test the methods, and then you have to deploy and configure it. That usually gives it like a version, and then you just invoke the API from a client for continued testing, right? So this is just mainly like creating a resource, defining and exposing methods on the resource, and then testing and deploying. So you start all that, by the way, by just clicking on create API. And they do have that pet store kind of like a sample API that integrates with the demo endpoints. It's pretty cool, actually. Even though it's like 3 or 4 years old at this point, it's still fun. So when you create an API, you can start from new. You can import from a Swagger definition. If you have a Swagger definition file, by the way, you could just do that. You could use the example API and modify it from there. So you could clone from an existing API. I don't know why that's not, oh, it is listed there, but it's not listed on the thing. You can select the endpoint type. So this is going to determine how the endpoints are deployed and accessed by clients. For example, this is where down at the bottom, it could say regional, it could say edge optimized. You could just say, look, this is private. This is only accessible from an Amazon VPC. I do not want to make this publicly accessible. Now, you do have to use, if you're going to do it inside of a VPC, you have to put a special network card in there called an interface VPC endpoint. That will allow you to hit that card, that network card inside your VPC to get to the API gateway. So just know you do have to set that up as an additional step if you go private on your thing, okay? My doorbell just rang while I was teaching. Now, here, notice, and I want you to put your eyes right on the center box where it says get/pets. And then it says get, and then you got post, and you got pet ID and all that stuff. Stay there for a second, right? So that's the structure of the created API, and it's basically like a tree, like a node tree, right? Because notice here that they're clicked on one little part, which is the pets method. Notice there's a get to the pets method. You can do a post, right? There's integration endpoints. This is actually calling like some other function, right? A Lambda function, an AWS service, an HTTP endpoint, a website, a web page. For each method that you define, you can identify the backend endpoint that you want to integrate with on a per verb basis. So depending on what, how you call it, you can actually go to different backends. You can also, by the way, create a transformation there if you want to transform the response either as you send it or as you receive it. Okay, this is cool. So like valid values for authorization is that you can use an IAM permission to control client access to the method. Only, by the way, users with role permissions can do that, right? So if you want to require an API key, you can do that as well. You can also obviously set external authorizers if you want to, like custom authorizers. That's under the authorizer section, which isn't necessarily listed there. So if you want to expand your list of authorizers, make sure you've added authorizers as an option. Here, if you're actually like on the actual method, you can actually choose test, right? Click the method name from the tree, then you can actually look at like modifying. You can do integration requests. You can change what the request and the response is on all sides of it. When it comes in, when it goes out to the integration on the back end, when it comes back from the integration on the back end, and then how you respond, right? So you can do with some transformations here. Let me just take a look at this really quick. Hold on. What are you doing with this exactly? Someone messed up the slides. Let me just change this really quick. Excuse me. You're like, Michael started editing the slides on the fly. It's like, yeah, nobody could read them. All right, there we go. All right. So select test, specify the invocation parameters, like how you're going to test, like in this particular case. And then request body is not supported for get methods yet. We know that. Then select like just test it at that point, and the test will execute. Here's the response log from a test, right? Successfully completed with a status 200. So the logs entry of this kind of output basically is going to show some state changes from the method request to the integration request, from the integration response on the back end all the way to the method response. So basically how the client talked to the gateway, how the gateway talked to the back end, how the back end talked to the gateway, and how the gateway talked to the client. That's all it is. I know we give them these fancy names like method requests and integration requests, but it's really just client to gateway, gateway to backend, backend to gateway, gateway to client. That's all it is. It's just the path of things as it goes from the client all the way to the backend and from the backend to the client. That's it. So this kind of thing, by the way, can be used for troubleshooting any mapping or transformation errors that have caused the request to fail. In this particular example, by the way, no mapping transformations were applied. Nobody changed dog to cat or cat to, alligator or fish to bird. Nobody changed anything. So it didn't show the transformations. If there were transformations, you would have seen the transformation show up, right? They would have been listed here. Not really a great example for that. So that's the response log. If you want to deploy the API, then what you do is you choose the top level root method and just go to actions and choose deploy. So after, to test using a client, you have to deploy it like to a stage, right? So stages are meant to kind of help like get it into a life cycle. For example, when you first build your API, you're going to deploy it to a development stage. Then you might deploy it to a production stage or maybe a testing stage and then a production stage. Once the deployment's finished, like the stage editor pane is going to show the URL that you're going to use to actually invoke the get method for the API. So there's other things you can set here, by the way, like let's say this is the demo stage and it's the stage editor. You can enable caching. You can set up the cache capacity. You can encrypt the cache. You can set the time to live for the cache, those kind of things as well. Remember, the default value for caching is 5 minutes. The maximum is an hour. If you set your TTL to 0, by the way, it means you're not caching. So just like disable caching at that point. Seriously. There's a bunch of other variables in here, a lot for API gateway. You can also set API throttling. So in addition to deploying things in stages that you can test independently, you can also just throttle an API. You can do it on two ways. You can limit it on the amount, like the rate, or like you can make it burstable. Like the default value for like burstability, for example, is like 5,000 requests or something. There are, by the way, default like limits that are bound by the account level. And if you want to shift them, you have to send a service quota request over to AWS to shift it. Alternatively, if you don't want to operate this at an account level for all of your API gateways, you can create what's called a usage plan. So a usage plan basically says, you know, hey, this is what the client can actually do. And you can apply a usage plan to a client for a particular like gateway. So, you know, like here, for example, the average number of requests per second, the default is 10,000 requests per second. You can rate limit that in a usage plan and shift it. Burstability could go to 300 or, you know, 1,000 or whatever number you want to define. Again, you can create a client usage plan and limit those on a per client basis. Like that way you can monetize like whatever they're paying for, right? You also document the API, right? You can actually publish documentation. Like there's like it'll like look at all the method and what's not, and it actually publish the documentation in an open API specification. I think it'll also create Swagger files if I remember correctly. So. By the way, oh, that's right. You can also generate an SDK for your API. So let's say you've done, you know, you got like 1,000 endpoints and methods and you did all this stuff, and you did it, and you want to like publish something like an SDK because you've monetized your product and you want to make it as consumable as possible. You just choose your platform and then do generate SDK. And by the way, it will ask you for additional parameters, which is going to vary by platform, and then generate it. And just to be clear, every time you update your API, you're gonna have to generate a new SDK. So just be aware of that. I thought that was pretty cool. I mean, it's not super sophisticated, but it definitely gets you started. Notice that this is for the demo stage. Looks like this particular one is for this particular like stage, if that makes any sense. Here's an invocation example where they are using the API endpoint URL, right, to invoke the API. They're creating a new HTTP client instance. They're setting up all the invocation parameters, and they're actually invoking the method. They've even like grabbed the API key from the config parameters, set the auth type to GET request. I think this is, I want to say this is, notice by the way, the SIG version 4 client config that's up there for that call. That looks pretty standard actually. So one thing to note is that with a proxy integration, the setup is simple because the input to the Lambda function is as is. So when the client hits the endpoint, it just gets submitted over to the client. That includes things like request headers, payloads, configuration data, right? So, you know, that's it. In general, people recommend that you use the proxy integration with a Lambda function because it's nimble and it's streamlined and it's versatile. And the custom integration is difficult to set up and it's a legacy technology, right? Yeah. A custom integration is not as flexible. The setup's more involved, right? You also have to specify how the incoming request data is mapped to the integration request. So data has been requested in, how does it map into the back end? And how the resulting response from the back end is mapped back to the client's response. So the client sends data, you're going to map that back to how that maps into the integration, the back end. And then the back end sends a response that has to be mapped out to how you're going to respond to the client. So, you know, it does require additional knowledge to set up, but proxy method is the one. But if you need custom integrations with Lambda because you need to control those transformations, you have the option. Just know that's considered legacy. And a couple of best practices. So one, when API client requests come from the same region, choose a regional API in type. Like, you don't need to go global. If you're just accessing it from the same location, don't force it to run through like CloudFront, for example. Test, load, like see how test caching parameters, like load test. Go through some failure scenarios. What happens if I submit this header? What if I make this request? Like, try to mimic as much production capability as you can. Gore, the grinder, those kind of things are all great replication tools for replicating traffic, including API web-based calls. And try like cache only get methods. I think that's pretty true. Obviously, if you're gonna like delete something, change something, you're not gonna cache that. It is worth just mentioning briefly about SAM. But before we do that, before we talk about the fuzzy squirrel, does anyone have any questions about any of that stuff around API gateway? All right. So SAM, the serverless application model, which again, I'm not sure why they don't always spell this out, but this is the serverless application model. So this is a CloudFormation extension that's optimized for serverless resources. Now, CloudFormation is a like templated way of defining all of your AWS resources. You submit the file into the CloudFormation service, and it builds out your entire infrastructure for you. So SAM supports, DynamoDB, Lambda functions, API gateway, and basically any resource that CloudFormation supports, which is pretty much all of them except for the really new stuff. Notice here that there's a transform section at the top, and then it's got a bunch of resources, including the handler, the runtime, code URIs, basic policies that get invoked. This allows you to use CloudFormation to define these kind of items like en masse. Now, other things, as far as our core scenario goes, is that how do we build an end-to-end scale kind of application? Because you may remember that when we looked at this before, I was like, hey, there's something missing from here, because how do we get from S3 all the way to Lambda? Now, don't get me wrong, S3 can invoke Lambda directly if you tell it to. But that's not really what we were asking the user to do. We were concerned about API calls. Well, this is how we solve that, is that now our website can do dynamic calls from, like, let's say client-side JavaScript. It can actually just call the API gateway, update the data, DynamoDB table, and then respond. So you can post, you can get, you can delete, you can do all the stuff, right? So this is where API gateway enables us to run a completely serverless setup, because now dynamic client side, for example, JavaScript, can just call these APIs directly. All right, quick knowledge check, and then we'll roll into the lab. Okay, true or false? API gateway enables developers to create, publish, maintain, monitor, and secure APIs. Does that sound like a true phrase? Or is it false? Yeah, sounds pretty good to me. monetize, right? Okay, next question, true or false? You can throttle and control API usage by using only a throttle rate. You can't throttle through any other method. You can only throttle rate. That's right, burst too. Good, Grace. Yeah, so burst and burst and rate, right? So you can throttle both of those. Good, so that's false. So this one is going to be interesting because the maximum number of concurrent requests that API gateway can fulfill at any given moment by default is what? What is the by default? Good, Hannah. Good. Why do you say 5,000? What does the 5,000 actually represent? What is that value? Let's go take a look at that. What was the value that we could look at? Let's go take a look at what the throttling said. The throttle rate, if you remember said correctly, like the burst rate was like 5,000, right? Where was that? Now I'm like, where was that exactly? I think it was here that we said that. You're like daily, like for example, like the burstable rate can only cap at 5,000, right? That's the default. I don't remember where that was now. Forgive me. But that's exactly correct, Anna. That's the limit, is that you can burst up to 5,000 as by default. So that's the most it can handle at any one time. Okay. Oops. Well, I pretty much gave you that one. So let's just go ahead and acknowledge that. So I gave you two of them, actually. Wow, I went way too far ahead. All right, you can ensure access to your APIs by creating a resource policy. I think we kind of talked about that a lot because even I was a little bit forgetful. I was like, oh yeah, that's right. API Gateway does have resource policies. Totally forgot about that. You can secure access to your APIs by creating a private API endpoint that can be accessed only by a VPC client. We did talk about that too, right? An interface VPC endpoint is a special network card that you can stick inside of your VPC that gives you access to what are normally public AWS services, like Lambda, like DynamoDB, like S3. In other words, you're in your availability zone inside of your VPC, but the S3 and DynamoDB services, they exist outside of your VPC. Most people don't get that. Your private virtual in the cloud, your virtual VPC network is private to you. The public AWS services actually live in another data center. So when you want to get to them, you got to go to the internet unless you use this private API endpoint. It's called an interface endpoint or a gateway endpoint, but interface endpoint is more popular because it's used by more services. So that's how you get access. And that way, when you do that, when you stick a network card inside your VPC, that's a private endpoint, you do not go over the internet to get to public services. You go through that network card and it runs you through AWS's private backbone. But you're like, Michael, why would you go from your VPC across the internet to get to other AWS services? Remember, the regional services are actually in a data center that's separate from where your virtual machines are running, because that's where you run your virtual machines, not where DynamoDB runs. Amazon's not going to co-locate that stuff, right? Good. Okay, last one. I didn't spoil this one for you, right? An AWS Lambda function could be used as a CRUD backend to intelligently handle a diverse array of API calls. Woo, that sounds pretty markety right there. Is that true or false? Can a Lambda function be used as a CRUD backend against like DynamoDB or RDS or whatever? Is that true or false? Yeah, that's definitely true. I mean, they want you to be impressed by the fact that you can do that, right? You can. Okay. Moving on. let's say you want to develop some solutions with AWS Lambda, because this is going to be lab 4. This is what we're going to do, right? Is we're going to take, we're going to create a Lambda execution role because we're going to take a numbers.txt file out of a bucket. We're going to like push the object name to the function. The function is going to grab the text file, process the file, send some logs to CloudWatch, and then you're going to view the logs. You're going to see the min, max, and the average, right? This is a pretty straightforward lab. Now, yeah, we'll get to that. If we, and by the way, it looks like these are all healthily warmed, so you can go ahead and start your lab if you want to. So open it up with me. Same thing, connect to your environment, choose the environment you want to work in, go to your relevant one. So you're going to create the input bucket. Now, just so you know, do not forget what you chose. You can do your initials or a random number as long as you remember what the bucket like name is, right? Be very careful. Do not switch out of the region that the lab starts in, which I believe is US West 2, which is Oregon. Create the bucket. You're going to download the numbers.txt file, download it to your computer, and then you're going to upload the object to your bucket to use it. Upload the file. You should see it's uploaded. That should be fine. You're going to review the execution Lambda function, which has already been created for you. You're going to add the execution role. Make sure you've got S3 read only and the basic execution role. Then you're going to create the Lambda function. 3.8 Python. By the way, note that some of these buttons are not going to look the same because Amazon's always changing the console. So don't get hung up on it. Try to look like so I want to be very clear. Some of you are seeing this for the first time, so do not beat yourself up. Just relax your eyes and try to like take in everything on the page, okay? And then you're going to upload the function in question, to switch to the code tab, edit the following details, add a trigger. So in this case, you're going to select S3 as your trigger, and the bucket's going to be all objects created inside your bucket. By the way, you can download numbers.txt and change the name of the file and upload it again in different formats if you want to test it out. You're going to choose your development environment, in this case, whether it's Linux or Windows. You're going to code your solution. Remember, you have access to the solution code if you need it. You're going to build and test the Lambda function locally. Did you see logging output from the print statements? Good. Here should it be. Then you're going to deploy the Lambda function after testing it locally. And then from there, you're going to see some expected outputs, right? Notice the memory size is 128, which is the smallest. Version is latest. Test the invocation, basically by testing like the invocation, through the console, choose test. And then from there, you're going to do a little challenge, which that, let's say you want to add a feature. What would you, like currently it returns min, max, and average. What would you add to the Python calculator so it could return a count of the numbers, right? Okay, that's it. So if you haven't hit hard start, go ahead and do that. This is typically a 45-minute lab, so we're going to check in around 3:30. If you finish before that time, please take a break. We're going to check in around 3:30. Otherwise, go to town. I am very interested. None of you should see provisioning lab at this point in time if you hit start right now. So please let me know if you still see provisioning, because Quick Lab said they fixed it. Yay. Gerald and Antonio, you're the ones I'm really concerned about. Seems like it seems to have caught you. Okay, cool.
Good. I had started my lab way early. So I clicked on it way early, so I'm good now.
Okay, good. Did you start it before I even warmed it up, or did it?
Yeah, I did.
Oh, cool.
So I ran provisioning for a while, but then by time,
Okay, good. Well, and you should have plenty of time since it gives you 2.5 hours to do a 45-minute lab. So good, perfect.
Cool.